Good morning. So question, how many of you have ever had to upgrade the software on a network switch? What about do things like swap out power strips for a rack of servers? What about upgrading BIOSes? All right, fair number of people. 2 years ago, this was basically my life. I would sit around in a chat room, wait for people to show up and say, hey, I need access to this set of machines because I need to reboot a network switch, I need to do something to them. This happened basically every single day for me. The job was kind of easy. You would look at a rack, say, okay, what's in here, move some things around, and eventually get to a point where maybe you couldn't move anything else around, but so you would eyeball it, you'd say, oh, this is like a web server, it doesn't really matter so much. And you decide that you'd go ahead and let the rack go down. Sometimes we were right, well, I'll rephrase that. Most of the time we were right, but sometimes we actually were wrong and that would cause problems here and there. But the main problem here wasn't really whether or not we were right, it was that this was actually really time consuming and it took a lot of people. On average, it took the person who was requesting to do the maintenance work, and then it took one of us as coordinators, sometimes more than one of us if it was multiple racks, for example. And then it took what we call service owners, who are the people who own the machines that are being worked on. So on average, you would say if you were going to take one rack down, it would take you 5 people to get that work done. And that wasn't really going to work for us. At scale, your problems generally only ever get worse, right? You've got more servers, more racks, more switches, more power strips, just more things that are eventually going to need to be worked on. On the other side, you also have more applications, so you've got more products, more key value stores, more indexing services, just more people to coordinate that work with. So really, it only gets worse unless you actually make it better. And the reason I'm here today is because I want to share what we did at Facebook to sort of get us a 2/3 drop in how many people are involved in this maintenance work. And I'm pretty confident that if you were going to follow some kind of model for yourself, you'd see the same kind of success. And as you'll see, it's actually pretty simple, but it works really well. So a little bit of info about me. I've been at Facebook for about 5.5 years. I started on our site reliability operations team, which is why you saw in the earlier screenshot it said SRO. Eventually, I moved on to our production engineering teams, ones that focus on automating day-to-day operations. So the main question was, how are we actually going to do this? How are we going to get to a point where we didn't have to spend as much time on this kind of work? First thing we said was, let's set a goal. Let's get to a point where the only person who needs to be involved in this is the person who needs to do the work. So if you're a network engineer and you want to reboot a switch, you shouldn't have to talk to anybody else. But again, how, right? The first thing we wanted to do was automate the maintenance process. You obviously can't do things by yourself if you have to learn how every single service at Facebook works, right? So we can't just have a wiki page with all the instructions for everybody. That wasn't going to scale. It certainly wasn't going to fit in somebody's head. So we wanted to make sure it was automated, but we knew we weren't going to automate everything on the first shot, so we had to simplify that coordinator role, the role that we used to play as SRO that was to go between us and different teams. The first thing I'm going to talk about is our automation process. A little bit of vocabulary because I'm going to say these words a lot. Service, when I say that, I really mean just an instance of an application. So it could be like a MySQL instance or Memcache, Nginx, Apache, whatever. The service owner is really the team that manages that service. So on our MySQL infra team at Facebook, they would be the service owner for this MySQL tier. When I say disable, I mean just stop sending production traffic to that machine so that if that machine goes down, you're actually not affecting people who are using your site or your service. And when I say enable, what I really mean is put the machine into a state where it can start receiving traffic again. It won't necessarily receive traffic right away, but you actually want it to be available. If you know a little bit about Facebook in this space, we have a tool called FBAR, which is the Facebook auto remediation tool. And it's basically a tool that looks for alarms that it knows how to remediate and acts automatically. It's got an API that talks to our monitoring APIs and to our config management systems so that it knows what to do. And then it's got alarm remediation plugins, which is the logic that actually gets executed in response to an alarm. And it has host-level operations that we use if we ever get to a point where, for example, if you have a hardware failure, there's no amount of code that's actually going to handle that. So we know that when we have a hardware failure, we need to make sure that machine is no longer taking production traffic, and then we get it repaired offline by one of our people in our data centers. The repair flow is basically like this. You detect a hard failure, we disable the host, get that host repaired somehow, and then put the host back into production by enabling it. And then you go back to this cycle, and this is basically what happens to a machine at Facebook for its entire life in production. We looked at this flow and we said, well, what we need to do is actually pretty similar. So we can take this and go beyond repair. We can use our repair flow or expand our repair flow to do this type of work. There's a couple of distinctions. Usually when you're thinking about the repair flow, it means that the machine's broken somehow. In this case, these are machines that have nothing wrong with them. They're healthy and they're in production. They're taking traffic, so you have to actually deal with that. We have an attitude at Facebook is we try to keep things simple. So we looked at it and said, well, schedule the maintenance that needs to be done, disable the hosts, plural instead of one, do whatever work you needed to do, and then enable the hosts and rinse and repeat. The first approach we took for this that we sort of demoed or prototyped was a serial approach. It was kind of, disable all your hosts one at a time. Once they were all disabled, do the work you needed to do. Then once you were done, enable all the hosts back one at a time. Again, rinse and repeat. So it worked pretty well. You would take things out of the rack serially. But we ran into teams, for example, that had code that actually intentionally replaced machines with machines in the same rack. This is sort of like to keep your network topology pretty consistent or to avoid things like transferring data between racks when you don't have to. But when you're doing maintenance work, you end up in this scenario where you're actually never really clearing things out of your rack. So that didn't work. What we also saw is that even if you actually did move things out of the rack, you could get into a scenario where you would move things out of your rack, but then you would end up with one thing that was left, and it was stuck there, and it had nowhere left to go. And if you're doing this sort of like manually, you can eyeball it and say, OK, I think this is OK. But if you're doing it with automation, it's actually riskier to just sort of like guess. So the serial approach, it was too time-consuming. For example, if you're doing one host at a time, if you have a machine that takes 4 hours to drain, like if you're waiting to transfer state over for 4 hours, that's already long. If you have 20 of these machines in one rack, then you're going to be stuck for a long time. It could be blocked by a single failure, which meant that if one of those machines failed in the data transfer process, for example, you'd actually get stuck and be like, OK, like what do I do now? And it was prone to these sort of like loops and deadlocks that I showed where you would either not move out of the rack or you would end up having nowhere to go. We said, OK, well, serial approach isn't going to work for us. Let's try a parallel approach. Again, following the exact same flow, except in this case, disable the hosts all at once, do whatever you need to do, and then enable them all at once. Now, what we found here is that you still run into problem situations where everything moves away, but if you had one host that couldn't go anywhere, it's stuck. So in the end, it's fast, which is great. So now you're really, you're as slow as your slowest host, but not as slow as 10 of them in a row. That's an advantage, but it's still not smart enough for us, and it's definitely not safe enough for us. The analogy I like to give here is that, for example, in our FBAR code base, we have a lot of things that do a check of like, oh, can I take this one machine offline? It's a very different thing to ask that question 40 times than to say, can I take these 40 machines offline at once? So that's definitely why the parallel approach needed something on top of it to be able to work. There was one more thing, which was the repair flow at Facebook. It's something that can take a few hours or a few days, depending on sort of like, well, do we have actually parts to fix this machine? Also, like, is this a higher priority machine that, of a certain type that we need to fix immediately, or is it something that could wait? When we were looking at the maintenance work that we were trying to optimize, though, rebooting a rack switch might take somewhere like 5 minutes. Swapping out power to an entire rack might take a couple hours. Swapping out a network switch might also take a couple of hours. But you didn't really have the same sort of expectation that your host would just be down forever. Well, not forever, but at least for a while until it came back. So we wanted to have the ability to sort of optimize how people would respond to this. So the automation we built, we call them aggregate maintenance handlers. And as you see, it's not exactly the easiest thing to say or pronounce. It's also long to write. But it does have the advantage that it actually describes what we do pretty well. We're doing maintenance across multiple machines, so doing maintenance across an aggregate of machines. And the first step to building these was to give them the full context of the automation, the full context of the maintenance work that was going to happen to our automation. So we give 4 items. We give it scope, which is just a long list of all the machines that are going to be involved in this maintenance. The impact, which is either a network switch reboot or network interruption or power interruption. The reason we have these is, for example, if you have a cache machine, you don't necessarily care if you lose network for 10 minutes, but if you reboot the machine and you lose everything you have in cache, that might take a while to warm back up. Finally, we had duration and time. Duration is how long is this actually going to last for? So that's the, an hour for a rack switch or multiple hours for power maintenance. And the start time, which is this is going to be happening at 10 a.m. tomorrow morning or at 9 p.m. tomorrow night to deal with things, for example, where you might not want to do the same thing at peak as you do in the middle of the night. So that information gets piped to what we call pre-flight. And pre-flight is really your first chance to make sure that things are going to proceed properly. If you remember, the serial approach and the parallel approach both had that problem where you could potentially get into a deadlock or not be able to move forward. This gives you a chance to sort of look at that input and say, okay, this is actually going to work. It also gives you a chance to say, there's no way in hell you can take like 90% of my service offline at once. And pre-flight either returns true or false, which says move forward or don't move forward. From a code standpoint, this is a pretty simple example. What we do is we check capacity. If that capacity is sufficient, then we return true. For any other reason, we return false. The important thing is we return false by default. We always want people to make sure that they only say yes to the things they know they can handle, as opposed to only say no to the things they know they can't handle, because it's actually much easier to predict what's going to work than to predict what might not work. Once pre-flight has succeeded, we move on to what we call the pre-disable stage. And this is essentially what you can do to disable spares in the serial approach example where you would stay within the same rack. That would guarantee that you move out of the rack. We also have some services where it's actually less churn for that service to just do one update than to do a bunch of consecutive updates. So one of the examples that I usually cite is our cache infrastructure. If you update your cache map once, you're going to cause a sort of like a sudden burst of of cache misses. But if you do it sort of like continually for 5 minutes at a time, like 10 times in a row, that's actually more like 50 minutes of cache misses. So it's actually better to do it in one shot. Again, the API is actually pretty simple. We just have this pre-maintenance disable method, in which case you would just disable the hosts in bulk, return true if that succeeds, and again, just to be safe, return false for any other condition. Once we've hit pre-disable and succeeded, we move on to what we call the host stage. And the host stage is really where we leverage what was available to us in FBAR. So all the host level automation, we just simply reuse it there and say, okay, just drain that one host. If you've already done stuff in your pre-disable method to disable the host, then this is probably going to be a no-op. We have some cases where people use the pre-disable to say, okay, let's start disabling these machines, and then use the host level automation to just wait until that one machine is done. So they just have a check that says, like, is this machine still in production or not? And as long as it says no, it waits, and then once it's no longer in production, it just returns true. And again, these either return true or false. From an API standpoint, it looks like this. The example I picked is disabling the host in the load balancer. You want to make sure that succeeds because you want to make sure that it's no longer getting traffic. then you try to stop the service. If you can't stop the service, that's actually not necessarily a bad thing because you're counting on the fact that the load balancer already disabled it. So you still return true anyway, for example, here. And then again, any other scenario, return false. Now, after all this host level automation is run, we pass this to our post disable. And your post disable does two things. One, it gives you the chance to verify that things are actually disabled. So if you're thorough, you could say paranoid, this gives you a chance to verify that everything is actually disabled. The other thing it does is, as you see here, it can inspect all the results of the host level automation, and then you can have a decision where you say, if I have an acceptable level of failures, I'm just going to proceed anyway. This is useful, for example, for something like a web service. If it's fairly stateless, you don't necessarily care if maybe like 1 out of 100 machines didn't get disabled properly. On the other hand, if you lose like 50 out of those 100 machines, you probably want to actually take a manual look at that. From an API standpoint, it gives you access to the impact, and then it gives you access to the jobs that are, to the host level jobs that we ran. So in this example, I just said, calculate the percentage of the failure rate, and if your failure rate is greater than 25%, return an error, and if it's less than 25%, just return true. The important thing with the post disable method is that if post disable returns true, that really means that your automation is promising that these machines are no longer in production and that whatever happens to them will actually not affect user traffic. So just to recap, pre-flight is your chance to do a capacity check, make sure that things are going to be safe. Pre-disable is where you can sort of do bulk operations or disable spare hardware. Host level disable is just the the parallelized host level automation that we've got in FBAR for our case. And post disable is your chance to verify if things actually work properly. I haven't talked about the enable flow yet, but it's basically the same thing in reverse. You just enable machines instead of disabling them. The one difference is we actually ignore the results for pre-flight because we've never had a team tell us, hey, you gave us back too much capacity. Mostly they're just like, we'll take whatever you give us. So that kind of covers the automation aspect of things. And the next part is how do we actually simplify the coordination aspect? So we built a tool that we call Dapper. And Dapper's main job is to, well, first use that automation. If that automation fails for some reason, we want to coordinate it with humans. So if the automation denied the maintenance, which would be like pre-flight saying, you're taking too much capacity, I can't actually do this automatically, I need to get involved, Dapper's job was to reach out to a human for it. If the automation fails, which could be like code isn't always perfect and sometimes you run into a problem, we also want to make sure that it coordinates with humans to not let people proceed on the maintenance work. And also if there's no automation. If there's no automation, then we revert back to depending on people to get this work done. From a flow aspect, we have a person creating the maintenance. So they say, this is the scopes I'm going to be touching, this is the impact I'm going to have, this is how long it's going to last, this is when I'm going to do it, and then they hit the create button. At that point, our automation kicks off the pre-flight stage. If you're creating this the maintenance for tomorrow, then we're going to run automation, or we're going to run pre-flight automation just about every few hours until tomorrow. And as long as it returns green, we're going to be in this pre-flight stage. If it's green, we then enter a scheduled stage. And this is the signal to the person who wants to do the work that they can actually start doing, the automation. So they hit a button which says start, and it will start disabling these machines. This goes to our disabling automation, which is the disable flow that I showed earlier. And when that succeeds, we enter a ready state, which tells the person, OK, all these machines are disabled. You're good to go on the work you actually need to do. Once that's done, once the person clicks the begin work button, that actually notifies the service owners that those machines are being worked on. They can do things like replace the switch, reboot machines, change out power supplies. Once they're done, they hit a work complete button. And that says, OK, kick off the automation that will re-enable those hosts back into production. And once that completes, you've basically completed your maintenance work. So this is all green, but I did have some paths that could lead to a red state earlier. So Dapper's job is, if pre-flight fails, enter this pre-flight block state. And that's a state in which Dapper will actually create a ticket for the service owners who manage those machines saying, hey, we need to do this maintenance. You guys don't have automation, or your automation says we can't do this. Please drain them manually, or please disable them manually. All they have to do is basically flip one bit on that ticket, and then once they flip it to say that their services have been disabled, we can go back to the scheduled stage. And similarly for the automation aspect, if that automation fails in the disabling phase, we do the same thing. We kick out to a ticket to the service owner and then wait for them to say, yes, my machines have been disabled before proceeding. And again, in the enabling phase, we say, hey, your machines are back. Just confirm that you know they're back and that you can reclaim them. So this is the flow that Dapper enforces. And where it's gotten us to today is that, like I said earlier, it's a 3x drop in the number of people involved in this maintenance work. You'll notice that the number of requesters is actually less than 1. The reason that is because we have some automation in places that detects, for example, that a network switch might be bad and might need to reboot. So this automation actually calls Dapper and says, hey, drain this rack for me. So we actually have less than 1 person requesting work. We've essentially eliminated the coordinator role. Now the requester sort of takes on that responsibility because Dapper will sort of give them it will give them the ticket numbers that they need to look up, and so they can actually go and use those ticket numbers to prod people to get work done. And the automation has allowed us also to get to a point where less than 1 service owner is involved for every maintenance that we do. So that's going from more than 5 people involved in just rebooting 1 rack to less than 2 people, which is a pretty significant win. So we built the framework, and we definitely learned some lessons along the way, beyond just sort of like what I showed earlier with the serial approach and the parallel approach. With the people who use Dapper and the people who depend on it, we had some blockers where the service owners that needed to implement the automation would basically hide behind corner cases. They would say, oh, I can't possibly fix every little thing that you want me to fix. I can't possibly automate every little chunk of work you might need to do. And what we said was, you don't have to bother doing everything. Solve for the common case. The common case for Dapper is that more than 90% of the maintenance work that gets scheduled really affects only 1 rack. That means that if you can handle 1 rack going down with automation, that's 90% of the maintenance work that will happen without you ever getting involved. The next aspect was that people are generally a bit skeptical of automation. They're skeptical that they're going to be able to write automation that's good enough. They're skeptical that other people are going to write automation that's good enough. For the people that were writing it, we said, be conservative. This is what I'm talking about when I was saying, you return false by default, and you only return true when you're certain it's going to work. But we also said, mistakes are going to happen. That's going to be OK. The main goal is to automate this stuff. It's not to be perfect 100% of the time. And then finally, we own the process. And what I mean by that is, to the people who are using Dapper sort of like as the customer side, we said, as long as Dapper gives you a green light and you follow that green light, if anything breaks, you're off the hook and we'll take responsibility for it. We'll guarantee that whatever happens, if the green light is there, it's because you were supposed to be OK. For the people who wrote automation, we said, as long as your automation gives us a red light, we won't move forward. So if for some reason you said your automation said don't move forward and something did go forward, we said we'll take responsibility for that and we'll make sure that we fix the problems and that you're not considered like your problem. And then from a people perspective, they're still slower than the speed of light, unfortunately. So that flow where we kick out where you kick out a ticket to the service owner and said, hey, can you please make sure your hosts are disabled? That still takes too long. Rather than optimize that scenario, we just want to keep pushing for automation. There's only so much you can do. There's only so loud you can make that ticket and say, you can text people and say, hey, your stuff needs to be disabled. They're just going to get annoyed with you. We just want it to not have to happen at all, so we keep pushing the automation aspect. And then another problem was we had emergent use cases. We had to be really explicit about the scope of Dapper and what we thought people should do with it. But what we also realized is we had to know why we built this tool. In our mind, we were building this tool that would disable and enable services, or servers rather. But really, we had to think about why people wanted to do that. And once we started thinking about that, we realized that we were really addressing some of their concerns. So when you're building a tool, you want to make sure that you know why people are using it, not necessarily just what the tool is going to do. So my takeaways here is really simplicity goes a long way. I think this automation is actually pretty straightforward. I don't really think it's mind-blowing, but it is pretty safe and it works. The process is pretty linear. We just disable machines, do the work, enable machines. There's not a whole lot of like loops you can get into. And finally, the easiest case covers 90%. So if you just handle one, if you just handle one rack going down, like that's going to be most of the work you ever have to do. And then from a technology perspective, you want to have capacity and safety checks. You want to have full context for your automation. You do want to have those bulk operations that we have in the pre-disable and post-disable and pre-enable, post-enable. But you also want to have those host-level operations because they're going to be useful in other contexts. And then finally, you need that coordination aspect. And another important aspect here is on the culture side, you do need to have that conservative approach where you say, I'm only going to do what I know can be done, because if you just sort of like get a little bit too cowboyish about it, you're going to cause problems and people are going to be unhappy with you. But you also have to have the willingness to iterate. You're not going to get this right the first time around. You're definitely going to have to work at it. But you need also the forgiving environment. So these things is, be conservative, but allow people to make mistakes. So 2 years ago, I was spending most of my time on IRC dealing with these kinds of stuff. Fast forward a couple of years, and I haven't really spent that much time on IRC, but I have spent a good amount of time staring at Keynote working on this presentation. So I went a little bit long, but I think we have a couple of minutes for Q&A. So if people have questions, there's a mic over there.
Thanks for this. It seems like it would have been even simpler to just turn the racks off and do your maintenance and turn them back on. So I'm wondering if the service owners don't already have to deal with that, maybe you should just make your racks a little less reliable. Or why didn't you do that?
That's definitely a fair point. I think for us, we would rather do it right than just pull the plug on things. I think when you can spend a lot of time designing apps to be more like tolerant, but if you can be nicer to the app anyway, you might as well do that.
So my question is really around the amount of effort that it required. So for something like this to disable hosts and then make sure that they work fine with that disabled condition, you sort of need every service owner to come and tell you, okay, this is how this module should work for my service. So what kind of effort did it require throughout the organization for you to achieve this?
So the approach we took is building the framework and then letting people adopt. We didn't want to be in a position where we had to implement this automation for people because it becomes really difficult for you to really transfer all that context, and it's easier for people to do it themselves. The workload, it really varies. We have, if you have a very stateless service, then it's probably going to be really easy. But if you have something like MySQL where you want to make sure that you transfer data off the machine if it's going to be off for a while, it's going to take longer.
How do you identify the scope for these applications when you're taking them down?
The scope is really just the list of machines that are going to be affected.
So if you've got, say, a couple hundred of these types of systems, and you can declare that it's okay for 80% of them to be down, how do you arrive at that?
Usually it's the service owner's knowledge.